Seventh grade lesson 9.4 is solving surface area problems. And so this would be the scenario like if you had a three-dimensional shape and you wanted to paint the whole outside of it, how much paint would you need for that? So you're covering the whole surface of it. How much would you need to cover the whole surface? I normally would handle this much like we did the composite figures, where I would just kind of identify, okay, what are all the shapes that surround the outside of this? What formulas go with that? And then fill in the numbers and calculate. And that certainly is something that you can use if you're more comfortable with that. But in this lesson, they show us this formula that we can use. And at first, I kind of was like confused by it. But as I thought about it some more, I thought, well, that's kind of a nice shortcut other than finding like 6 or 10 different shapes that I need to deal with and getting their formulas for them and everything. So, like I said, if you go through this lesson and you feel like Miss Sanchez would rather just identify all of the shapes on a piece of paper, identify the formulas, fill in the dimensions for those formulas, and then add them together, I'd rather do that. You certainly can do that. Let's take a look at what happens in this lesson, though, in case you like to use this formula as well. Okay, so we have this three-dimensional figure, this rectangular prism. It's got a length 15 millimeters, width 8 millimeters, and height of 20 millimeters. And if it was like cardboard box and we could cut this correctly and just lay it out flat, you'd have your bases here, here. Well, actually, this is the base 8 by 15. So the base here is the way they cut it. And then this whole area here, they call it the lateral area. The whole part around just unfolds, and there it is as one big rectangle. Now, if I wanted to find the area for each of those, I have these two that are the same. I could find the area for them, 8 by 15. And then I have these two that are the same and these two that are the same. And so they start off by doing that. They say, you know what, go ahead and find the lateral area. They're talking about this part here, the lateral area. We have two that are 20 by 8. And then we have two that are 15, these two here, that are 15 by 20. And so I would calculate those. This one's going to be 160 times 2. And this one is going to be 300 times 2 added together for a total of 920. So I multiplied this and got 320, multiplied this by 2, got 600, added those together for 920. Its area, so millimeters square, or to the second power. That, remember, took care of all of this as one giant rectangle, rather than do these two. Well, we did these two and then these two. That's what we did here. But altogether, it ends up being one big rectangle. Then they say, okay, now take care of your two bases. You've got two bases, this one and this one. So we're doing 2 times the area of the base. So the area of the base is 15 times 8, length times width, right? And 15 times 8 comes out to be 120. And 2 times 120, because I have two of them, this one and this one, 2 times 120 will be 240. And then I will add the 920 to the 240 for the total surface area of the whole thing for 1,160 millimeters squared as the surface area. So what they're hoping you'll realize here is when we dealt with the lateral section, right, we looked at it as these two rectangles and these two rectangles, right? Let me neaten this up over here. I've been drawing all over it. And what they're telling us is, hey, you know, if you wrapped this back up, this box back up, right, this length is that. And this length is that, and this length is that. And if you add all of these together, then you really get the whole length of the big triangle. And remember, when we're talking about a shape, we have this side we add together with this side, we add together with this side, we add together with this side. That would be perimeter. Remember the distance around it? And this whole box would enclose around it. So if we took the perimeter of the base, then what we're really doing is taking the whole length of this whole rectangle. And then the height, of course, stays the same. So they ask us, use the net above to answer this question. How does the product of the perimeter of the base right here, the product of that with h, with the height, come out? And so if I added the perimeter of my base, 15, I'll draw the base here so we could see it again. That base was 15 and 8, right? If I did perimeter, I would add all of the sides together. I have 15 plus 15 is 30, 8 plus 8 is 16. It's a total of 46. And then they say product, that's multiplication. We're going to do multiplication times the height, which was 20. And look at there, ta-da, 920 took care of the lateral. So they're helping you recognize, oh, just take the perimeter of the base and then multiply it by height, and that really is taking care of the big rectangle, the whole lateral area, instead of doing them as 4 different shapes. Okay, so let's look at that in action. And in the next slide, they give us a formula that we can use. All right, so here is what they were showing us in the last lesson. Here's the formula, and it looks really confusing right now, so let's translate it. This is saying the surface area of a shape can be calculated by taking the perimeter of the base. So if that's my base, I take the perimeter, 12 plus 6 plus 12 plus 6, and I multiply it by the height of 15. And then when I get that answer, I will add that to 2 times the base's area. So 12 times 6 is my base area, and then I would just multiply that by 2. So this represents the perimeter of the base. This represents the height of that lateral part. This represents the 2 bases that I have, and this represents the area of one of those bases. So let's put this into action. Okay, so and I'm going to go ahead and draw this out as a net with my base here, just so your brains can see it, and mine too. Oh, I ran out of room. Okay. And then we unfolded this box with this here, and then it goes down this way. We have the part that would go, this is not right. This needed to be longer. There, and then we have the part that would wrap around. So pretend these are the same. It's a box. It should have come out the same. I'll fix it. Okay, there it is with the measurements there. So I chose this as my base. That's this part here, this 6 by 12, 6 by 12. And then I uncut here, flopped that thing open so that it's all laid out. And I have this length of 15 here. So that's the measurements there. So they want me to take the perimeter of the base. I chose this as my base. And so this is 6 plus 12 plus 6 plus 12. So that's 24, and 12 more gives me 36. So now I have 36 times the height, which is 15. And what that calculation is technically doing is it's taking the perimeter said all of this plus this plus this plus this. That's what the perimeter's base gave me, because we know this amount wraps perfectly around that 3D shape. This plus this plus this plus this. And then we took the height, which was 15, and that's going to give us the area of the whole big rectangle instead of doing 4 different ones, which is kind of handy. 36 times 15 is 540. Now I'm going to address the area of the base. The area of the base, this is my base, and it's a length times width, so it is 6 times 12, which is 72. But remember, I've got two of those. I have this one here and this one here, those two. So I will multiply that by 2 bases. So 540 over here added to 2 times 72, which is 144. And I just add those together for a total of 684 inches squared. So basically what this formula does is turns this big rectangle into a big rectangle rather than 4 separate ones, and then you just deal with your bases. That's the area of your bases. That's what this formula does for you. Okay, let's look at another example because it's one of those things that the more we see it, the more it starts to click in place. I'm going to write that equation. The surface area will be the perimeter of the base times the height of that lateral section, and you'll add that to the area of the 2 bases. Okay. So let's have a look at what we have here. A brand of uncooked spaghetti comes in a box that is rectangular prism. So rectangular prism, I'm going to draw that, sort of. And it has a length of 9 inches, a width of 2 inches, and a height of 1.5. I'm going to make that 1.5 because I'll probably be using my calculator to do the calculations quickly. And if you're in my class, you're welcome to use calculator on these. So your addition and multiplication calculations can be done very quickly. So instead of 1.5, let's put 1.5. Same thing, right? Okay. So I'm going to choose this part here as my base. This is a 9 by 1.5, and I'm going to draw it separately from everything. 9 by 1.5, because the base becomes that key piece of information that we need in order to fill in this formula. So the first thing I'm going to do is use the base to find the perimeter of the base. Okay, well, that's 9 on this side as well, and 1.5 on this side as well, so I just add that all up. 1.5 and 1.5 together is 3. 9 and 9 is 18, so add that 3 to it, equals 21. So I have a perimeter of 21. So in place of P, I'm going to put 21. The height, now remember, this is the height of this part all laid out flat, right? So this ends up being the height. We laid it all flat. We took the perimeter and as if it was laid all flat. And then this would be the height. So that's 2. And now we need 2 times, because we have 2 bases, the front and the back over there, 2 times the area of our base. And our base, again, was 9 by 1.5. So area is done by by the length times the width. So we're doing 1.5 times 9, and that is 13.5. And now I'll just calculate these. 21 times 2 is 42. 13.5 times 2 is 27. Add these together for a total of 69 inches square. So there's that use of that formula again. It's one of those things, the more time you see it, the easier it becomes. Our next example is a surface area of a composite solid, and so we have a birdhouse shape, and I'll walk you through how that's used too. Okay, so we have Daniel who built a birdhouse shown. What was the surface area of the birdhouse before the hole was drilled? Okay, and so that's good because and we could have handled it, but they are saying we don't have to worry about this hole. We're going to assume that wasn't drilled in there yet. Now, we could have done it. If they had drilled the hole, we would have found the whole surface area. Then we would have found the area of that little circle and subtracted it from the whole thing. But for now, thankfully, they're not asking us to do that. So, no problem. Here we go. I notice that I have 2 prisms. I have this rectangular prism, and then I have this triangular prism. So I'm going to have to do those separately and then add them together. So I'll use the formula for the rectangular prism here. And then I can use this same formula for the triangular prism as well, as long as the base that I use is this triangle. So let's start with the rectangular prism. And as the base, I'm using the very bottom, so the butt that it's sitting on, right? So I'm going to draw that out, what it would look like. And its length is 30, and its width is 24. Okay, so that's the bottom that the bird house is sitting on. It's 30 by 24. Now, if I took all of these lateral pieces, cut them off of there and laid them flat, they would all have a length 30, 24, 30, 24, right? So that's why we use the perimeter. So I'm going to do the perimeter of my base. That's 30 plus 30 is 60. 24 plus 24 is 48. And 60 plus 48 is 108. So I have a perimeter of 108 for here. Remember, that's all my lateral. The height of all my laterals all the way around. So the length is 108. The height is 18. And that's going to give me the area for the whole big rectangle of that flattened part. I undid the box, laid that flat, so those 4 pieces are into one big rectangle. And that's what those numbers represent. So I will do 108 times 18 to find out the area for that whole big rectangle that this whole part all the way around makes. Then I will add to that the base. And actually, I'm going to talk to you about this base real quick too. Notice in our on our drawing here, we have that bottom part, the base, that we're dealing with. The opposite of that is this top part, right? But our top part is covered up. So let's reason that out early, save ourselves the calculation later. I don't need 2 of them, right? I only need the bottom one. The top one's covered. So let's only do 1. So there's a little bit of reasoning skills that go on here. So we're just going to do one area for the bottom, the base. That is 30 times 24. To get base times height, the length times width, 30 times 24. And that will equal 720. I only need 1 of them, again, because this top one is covered up. So that's why I didn't multiply it by 2 in this circumstance. So you can reason things out like that. I need to do the 108 times 18. And that is 1,944. Add those together. And my surface area of the rectangular prism, excluding the top, because I didn't count him in, excluding the top, is 2,664. That's just the rectangular prism, not counting the top. Let's look at our triangular prism now. We use the same formula. S equals the perimeter of that triangle times the height plus 2 times the area of the base. So let's look at our base. It is a triangle. We have to use a triangle part for our base so that we're using the correct area calculation. So I have a length of 30 and a height of 8. Remember, and then I also have over here, because we're going to take care of that perimeter first, I have this value here that's 17. And this is 17. So 30 plus 17 gives me that perimeter so that when I uncut these pieces from the box and I lay them out flat, that tells me their whole length for the rectangle. So 30 plus 34 is going to be 64. The 34 I got was the 17 plus 17, by the way. And then I'm going to multiply that times the height. And now remember, this isn't the height of the triangle here. This is the height of this when I lay it out flat. So I laid it out flat. The perimeter gave me the whole length this way. The width is going to be this part on that laid flat rectangle. So that's going to be 24. And I would add that to the area of the base. And there's two of them. This one and that one. So I am going to multiply by 2. And I know you're probably starting to look at this and go, there's an issue because that's sitting on top of that. Yeah, we'll take care of that in a minute. So the area, again, we just have to refresh our memories. Area of a triangle is half base times height. So I'm doing 1/2 of 30 times 8. I'll do half of 8, which is 4. And 4 times 30 is 120. I'll get my calculator out. Well, this one I can do in my head is 240. 64 times 24 is 1,536. Add that together. And that's going to be 1,776. Okay. Before I go adding this one together with this one, there's one more thing I have to address. And some of you may have noticed this. Remember, we had to leave the top off of this one because that's not going to be painted or whatever is the surface area. That's not a surface. That's inner. Same for this bottom of the triangular pyramid that's sitting on there. So we do have to find out what the area of that underneath part is and take it out. Well, it's the same measurement as this 30 by 24 that we did before for the base of this guy. It's 720. So I'm going to go ahead and cut that out of there by subtracting it away. And I will get 1,056. So the surface area of the triangular prism is 1,056. Now all I have to do, without the bottom of it that's already sitting on top of the other, right? Now all I have to do is add together the surface area of the rectangular prism that doesn't have the top on it and the surface area of the triangular prism that doesn't have the bottom on it because it's sitting on top of the other. And I get a total of 3,720 centimeters squared all together. And so deep breath, whew, that's a lot, right? If you understand all that happened, I mean, it's a lot of pieces and a lot of work, and use the calculator, but if you understand the use of this and what all of this represents, definitely use it. It's a much shorter version than the alternative. But if you don't, the alternative is to identify all of your shapes, like we did in the previous lesson. How many of those shapes do you have? What is the formula for doing those? Plug in the dimensions and calculate it. I'll show you that in the next slide, how to do this exact same one, but just piecing it apart. If this makes you overwhelmed and you're like, I know it's going to be more paper to do it. Can I just do it the way we were doing it before? The answer is yes. You can do it that way. I will show this one to you that way in the next slide. If this all made sense and you want to be using this and you don't want to use the other way, you're welcome to stop this video and go on to do the rest of the lesson. Those of you who want to see this one broken down by each piece because you don't want to deal with that, I'm going to show you that right now. Okay, my friends, so if you are feeling like I'd rather do this, just break it apart and deal with it that way. I hear you. I'm that way too. I like to see all the pieces in action. So here's how I would solve it that way. I would start by looking at my matching sides. I have this front and a matching back, right? And that measurement is a rectangle, a 30 by 18. So I have a rectangle that is 30 by 18. There's two of them, so I'll put that there. Next, I have this rectangle, and it has a matching pair on the other side. This is a 24 by 18 rectangle. and there's 2 of them. Then I have the bottom of that, the base that it's sitting on, but not the top. And that's a 30 by 24. So I'm going to draw that. There's only one of them. Then I'm going to look at these shapes. I have this triangle in the front and in the back. There's 2 of them. It has a base of 30 and a height of 8. Two of them. Then I have this rectangle matching this rectangle, right? This has a length of 24 and a width of and a height of 17. So, and there's 2 of them. 24 by 17. Okay, I think I've gotten all the shapes. This one, these 2, I should say, the 2 front and back here, the 2 front and back here, the 2 sides, and the 1 on the bottom. Now I'm going to take down my formulas. I have a rectangle, base times height. Rectangle, base times height, or length times width, same thing. Triangle, half, base times height, and another rectangle, base times height. Let me plug in my coordinate, or not my coordinates, sorry, my dimensions. 30 times 18. 24. Let me write that neater. 24 times 18. 30 times 24. 1/2 times 30 times 8. And 24 times 17. Calculate those to get their answers. They're all going to be eventually added together. Calculate those to get the answers to them. 30 times 18 is 540. 24 times 18, 432. 30 times 24, 720. 1/2 30 is 15 times 8 is 120. And 24 times 17 is 408. Now, this is important not to forget this part. Remember, I had certain numbers of these, and this is the calculation for only one of them. So this one, I need to double. 540 times 2 is 1,080. 432 times 2, 864. I only had one of these. I had 2 of the triangles though. So 120 times 2, 240. And I had 2 of these. This was representing the roof up here. 408 times 2, 816. And then I just have to add them all together. I don't have to subtract anything because as I went through and pieced these out, I left out that top one of the rectangular prism and the bottom one of the triangular one. So I didn't have to do it. So I get 1,080 plus 864 plus 720 plus 240 plus 816 for a grand total of 3,720 centimeters squared. So again, if the formula isn't something that you like using and you are just more comfortable taking up all the paper and piecing things out so your brain can see, okay, these are all the parts I have, these are the formulas I'm dealing with, plug in the dimensions to that, calculate. Don't forget that you have multiples of them. Maybe you do that calculation early if you're worried you're going to forget it. You can do that calculation earlier on if you want. So this is a perfectly good option for solving these if that formula throws you off too much on the previous example. So use that if you like it better. Good luck.